Welcome to our lesson on the integration of trigonometric functions. In calculus, trigonometric integrals are among the most important types of integrals you'll encounter. They appear frequently in physics, engineering, and many other fields. Let's start with the basic trigonometric integrals that you should memorize. The integral of sine x dx equals negative cosine x plus c. The integral of cosine x dx equals sine x plus c. The integral of tangent x dx equals negative natural log of the absolute value of cosine x plus c, which can also be written as natural log of the absolute value of secant x plus c. The integral of cotangent x dx equals natural log of the absolute value of sine x plus c. The integral of secant x dx equals natural log of the absolute value of secant x plus tangent x plus c. And the integral of cosecant x dx equals natural log of the absolute value of cosecant x minus cotangent x plus c. Let's visualize what the integral of sine x means graphically. Here we have the graph of sine x. The integral of sine x from 0 to pi represents the area under this curve from x equals 0 to x equals pi. Using our formula, we get negative cosine of pi minus negative cosine of 0, which equals negative of negative 1 minus negative of 1, equals negative of negative 1 plus 1, equals 2. We can see that this matches the area under the sine curve from 0 to pi. Now, let's look at how to integrate powers of trigonometric functions. When working with powers of sine and cosine, we often use specific reduction formulas or substitution methods. For example, to integrate sine squared of x, we use the identity. Sine squared x equals 1/2 times 1 minus cosine of 2x. Similarly, for cosine squared of x, we use cosine squared x equals 1/2 times 1 plus cosine of 2x. Let's work through integrating sine squared of x. First, we substitute our identity. Sine squared of x equals 1/2 times 1 minus cosine of 2x. So the integral becomes 1/2 times the integral of 1 minus cosine of 2x dx. This gives us 1/2 times x minus 1/2 sine of 2x plus c, which simplifies to x over 2 minus sine of 2x over 4 plus c. One powerful technique for integrating trigonometric functions is u substitution. Let's see how this works with an example. The integral of sine of 3x dx. We'll let u equal 3x, which means do equals 3 dx, or dx equals do over 3. Substituting, our integral becomes 1/3 times the integral of sine of u do. Using our basic integration formula, this equals negative 1/3 cosine of u plus c. Now we substitute back. U equals 3x, so our final answer is negative 1/3 cosine of 3x plus c. Let's now look at integrals involving products of trigonometric functions. For these types of integrals, we often use product to sum formulas or other trigonometric identities. For example, let's integrate sine of x times cosine of x dx. We can use the identity. Sine of x times cosine of x equals 1/2 times sine of 2x. So our integral becomes 1/2 times the integral of sine of 2x dx. Using u substitution with u equals 2x, we get do equals 2 dx. So dx equals do over 2. After substitution and integration, we get negative 1/4 cosine of 2x plus c. Alternatively, we could have used the formula. The integral of sine of x times cosine of x dx equals negative cosine squared of x over 2 plus c. Sometimes we need more advanced techniques like integration by parts for certain trigonometric integrals. Remember, the integration by parts formula is the integral of u times dv equals u times v minus the integral of v times do. Let's try to integrate x times sine of x dx. We'll choose u equals x and dv equals sine of x dx. Then do equals dx and v equals negative cosine of x. Applying the formula, we get x times negative cosine of x minus the integral of negative cosine of x times dx. This simplifies to negative x cosine of x plus the integral of cosine of x dx. Our final answer is negative x cosine of x plus sine of x plus c. Trigonometric integrals have many real-world applications, particularly in physics and engineering. For instance, when analyzing pendulum motion, we often need to integrate trigonometric functions to find the position of the pendulum at different times. In wave theory, trigonometric integrals help us analyze the energy of waves and the interference patterns they create. In electrical engineering, They're used to analyze alternating current circuits, where voltage and current often follow sinusoidal patterns. To summarize what we've learned about integrating trigonometric functions, first, memorize the basic trigonometric integrals like sine, cosine, tangent, and their reciprocals. Second, for powers and products, use trigonometric identities to simplify the expressions. Third, use substitution techniques for functions like sine of ax or cosine of bx. Fourth, for more complex expressions, use integration by parts or other advanced techniques. Finally, practice is key. The more problems you solve, the more patterns you'll recognize. Thank you for watching this lesson on the integration of trigonometric functions.